So in the last video, we were talking about doing a confidence interval for the slope. Now we're going to talk about our other inferential task, which is doing a hypothesis test for slope. And the first step for hypothesis testing is always state the hypotheses. And when we're doing a hypothesis test for slope, our null hypothesis is almost always that beta 1 is equal to 0, and our alternative hypothesis is almost always that beta 1 is not equal to 0. And so this null hypothesis would mean there's no relationship or association between the explanatory and the response, and the alternative would be that there is a relationship. So if we're thinking about our test statistic, that's our point estimate, B1, minus our null value, the number that shows up in our null hypothesis, and that's 0. And then we're going to divide by the standard error. So just like with a confidence interval, I will give you B1 and the standard error from technology. And then what you're going to need to do is find your t-value and then use that to find a p-value using a t-distribution with n-2 degrees of freedom. So let's try it. So we're gonna look again at R. We've got our output, we've got our estimate for the average temperature, and we've got our standard error. So then we're gonna find our t-value, which is B1 minus 0 over the standard error, and that's 4.802 minus 0 over 1.084, and that comes out to be about 4.43. And now we're going to find a p-value in a t-distribution with 88 degrees of freedom. And again, that 88 degrees of freedom was also in the R output. So let's go to stat key, remembering our t-value of 4.43. So we're on stat key, we're going to go to theoretical distributions, the t-distribution, and put on our degrees of freedom, which are 88. And then we have to think about, is this a one-tail test or a two-tail test? And it's a two-tail test because the alternative hypothesis has that equal. So I'll click the two-tail button, and then I'm going to adjust that critical value. Instead of having it be 1.987, I'm going to put in my critical value, which was 4.43. Okay? And then this gives me my p-value. So I've got 0.000014 on one side and the same thing on the other. And so I'm going to multiply that number by 2 to get my p-value. So my p-value is 0.000028. And then the question is, are we going to reject or fail to reject our null hypothesis? And these values were really far out in the tails. We have this really small p-value, so we're going to reject the null. So we have evidence to suggest there is a relationship between average temperature and volume on the rail trail. And this slide says confirm the calculations for the rail trail example, because actually these numbers were already calculated for us by R. We've got our t-value of 4.428, which is the same thing that we found, and our p-value of 2.7 times 10 to the negative fifth, which is 0.000002, something like that. It's the same p-value that we just found. So if you have the whole output, then you actually already have the p-value there.